Hi, it's Richard here from Past That Science. It's lunchtime. I just thought I'd go through some drawings, some earthing systems. You may be asked to do that. Typically it's the TNS or TNCS earthing system that I'll take you through because they're the typical ones that you might get. So we call them earthing systems. Now, definition of a system is something that has a source of energy, which in this case is the DNO distribution transformer secondary winding, and an installation. So if you started your drawing off with something like what you're seeing on the screen here, that would be a really good place to start. And really kind of every earthing system has this, it's quite common to both. Now we can label that. There's your line conductor, your neutral conductor. I've also added the label there for your DNO distribution transformer secondary winding. And this little chappy up here, of course there, that is your overcurrent protective device for that circuit. Every TN earthing system or every T earthing system has then the source of earth, which is shown there, and that is then tied to half of our supply system at that point there. They call that the earthed neutral point, and that is what gives us then our neutral conductor. That's what keeps the neutral at zero, the fact that it's been bonded there at that point. So your drawing will need to see this source of earth as well. Also on every installation you have an earthing arrangement inside the installation where the exposed conductive part, that'll be the metalwork of the electrical equipment, like say the body of the cooker or the body of the heater that's metal. That would then be earthed via your CPC, either a separate earth wire inside a conduit or trunking, or the earth wire inside a twin and earth that goes to your main earth terminal, then the main earthing conductor, which then is what provides the main earth terminal from the source of earth. Now the things that are common to all the earthing systems really are what are on the drawing here now. So regardless of what the earthing system is, if you was to start off with something like this, that would be a great place to start, because you might be able to pick up a point or two for what you've just done here. You've not actually included the entire earthing system yet. Now, what does TNS actually stand for? Of course it means that the earth, that's the source of earth, is supplied via a completely separate earth conductor, and that is shown here, though it says metallic return path, because that could be a number of things. It could be the lead sheath of the cable that's in the road, the distribution cable. It could be a separate earth wire. I've seen all sorts of things. It could be an arm ring, it could be the outer sheath of an MI. But that's all provided by the district network operator, the DNO, and this would be a TNS because it has a wholly separate earth wire. Let's now have a look at TNCS. I'm sure you've been talking in your lessons about what the different letters mean, but you have the T and the N, where the C then means it's a combined, which then separates at the installation. Let's see what that looks like. As before, every drawing has the source of energy and the installation. So if you was to start off with something like that, that would be a great point to start. Line conductor neutral, your DNO transformer secondary winding, overcurrent protective device. Source of earth as before, and of course then the earth neutral point and the installation earthing system. So you have your exposed conductive part that are connected to earth. They're earthed via your circuit protective conductor, which is connected to the MET, probably in the consumer's unit, and then the earthing conductor that then provides the MET from the source of earth. Now, the characteristics of a TNCS are that this conductor here then is a combined neutral and earth, which then as it enters the installation, the consumer's installation then splits out and separates into a separate earthing conductor. Now that combined earthing conductor is what we call the PEN conductor. So this is your PEN conductor here, and it was so the electricity board didn't have to spend too much money on copper, because if they were able to combine the neutral and earth, it saves them a bit of money in copper. So it's combined at this point. This is your TNC, which from here onward then becomes S. It's at separate neutral and earth conductors. So what you also might get is, along the distribution system, the electricity board will bond that PEN conductor to quite a few places along its length to earth. They might bang other electrodes in or connect it to other earths at multiple stages, multiple times. Virtually every join you'll find in a TNCS network, they may even connect an earth onto it there. So that may be then hence the term protective multiple earthing. You may have heard of PME. PME is where you have a TNCS earthing system, which is earthed at multiple points along the network. So in any case, drawing a TNCS earthing system, if you were to produce something like that, even if it was without those multiple earths, that really would be something. That would be a definite 3-pointer, because it's got everything in there. The important points, you're going to need to have that PEN conductor. That's got to be in there, definitely. And then this part here, then to show that you've got your PEN conductor that then separates into separate neutral and earth conductors. That's really important if you're drawing a TNCS. Those I'd expect to see. PEN has to be there. And then separate neutral and earth at the installation has to be there. So let's go through the terminology then. PEN, as we said, is the protective earth and neutral conductor. Now, we don't have PEN conductors within an installation. These are all outside in the DNO distribution system. And what the PEN conductor is, it's that combined earth and neutral conductor that's within a TNC or TNCS earthing system. That is the PEN conductor. And that's what it means, protective earth and neutral. CNE may be a term that you hear occasionally. CNE means it's a combined neutral and earth conductor. It's essentially the same thing as a PEN. And the other term that comes up occasionally, PME. It's where you have additional or multiple connections to earth on a TNCS earthing system. PME stands for protective multiple earthing. Multiple because it's earthed, the neutral and earth connection is made at multiple points along that system. So I think there's a minimum kind of standard that you'd expect to get for a drawing. I've seen students, you wouldn't believe the things that students have drawn in the past. But imagine if you were asked to draw a TNCS earthing system, something like this would suffice maybe. So you'd have your source of energy, which is the supply authority transformer secondary winding. You would have the line conductor. Naturally, you're going to do this with a pencil and a ruler. An installation, and this then is going to be your neutral conductor, and you might want to label it as well, even if you just put L and N to show us that. Everything is going to need, every drawing is going to have that source of earth. I'd say the more smarter people would divide up the two halves, one half being the consumer's installation, the other half being the district network operator's installation. Now, what makes this a TNCS earthing system, as we said is before, it's the fact that we've got this PEN conductor here, and you will need to label that as a PEN. If I were marking it, I'd definitely want to see some sort of indication where the PEN conductor is, and an indication there that the earth is then taken, separated out. So yes, it's earth, but also if you wanted to put, of course, that's your circuit protective conductor. So that I would say is absolute minimum standard, because it has got it. It's got your supply authority transformer, it's got the load, it's got the line conductor, the neutral conductor, it's got the earth, and the fact that you've got the PEN conductor. Very, very important that you do put that in there. So do make sure that you do put PEN conductor. And do show that arrangement there, because that is quite unique to TNCS earthing systems. Thanks for watching. Now go past that science.